Saad, are you there in the class, dear? Am I audible to you? Saad, let's wait for 2 more minutes because some more students are there. Okay, so what happens, Saad? You have any internet issue or something else? Okay, okay, check. Actually, your voice muted, so that's chalo, check it. Okay, so let me ask whether somebody is joining or not. One more last time. Other then we'll start. How many of you have done the revision? Be honest with me before coming to the class. Raise your hand in the chat. How many of you have done the revision before coming to the class? Arham, Samia, Sarah, Hanan. Okay, Samia did it. Hanan, Saad, Arham, Arhan. Only one. Okay, Saad, no worries. Only one student have done the revision. That is Samia. What about rest of you, bachu? Why? Hanan, what's your reason, dear, for not revising the concepts of previous class? Hanan?
I revised it after the class.
No, I'm asking like right now before joining the class, have you done the revision?
No.
No. Why?
I revised it after the class. That's
Here, before coming to the class, actually, you should revise the concepts that we have done because the thing that we are doing right now in the class is related to the previous class. So you should have done the revision. Okay. Saad,
I'll do.
what's your reason, dear, for not revising? Have you done the have you revised the concepts before coming to the class? Arhan, are you there in the class? Assalamu alaikum. How are you, dear? Arhan, am I audible?
Yes, sir.
How are you?
I'm fine, sir.
Okay. Have you done the revision, dear?
Yes, sir.
Okay, chalo, guys. Sarah, have you done the revision? No. Why? Here you are not revising the motion, you are not revising the force. How you will do the further concepts? You are taking physics classes. If you do not revise, how you will cope up and solve the physics problem in the exams? Let me know your strategy. What's your strategy when you will sit in the exam? If you are not revising, what you will do? Any idea? Is there any genie that is going to help you? जी हुकुम मेरे आका. Is there anyone that you have? That's why you are not revising. Huh? No, that's not going to make sense, dear. If you do not revise, you will be in very big trouble. Everyone, it's not specifically for Sarah. It's for all those who are not revising. Because the thing that we are doing, like ninth physics, is not is not like candy, just like the eighth class. It's very tough. I'm seriously saying it because when I was ninth class and when I've gone to 10th standard, when I compared, so ninth physics was very much tougher than the 10th standard. 10th is like very simple, straightforward, but ninth physics have very detailed concepts. If you do not catch it, if you do not revise it, nothing is going to happen. Okay? So it's a request to everyone, at least before, give 15 minutes to the like to yourself for the revision before the class. Just 15 minutes. Okay, let me enter. Some students are about. Okay, so Arhan, please switch on your camera, bacho. Okay, so let's start it. So in the last class, I've told you about the momentum of a body. So I've told you that momentum is the basically is the product of mass and velocity of a body. It tells you how much motion is there in a body, right?
Yes, sir.
Yes, sir.
Okay, is this clear, everyone? So the okay. Now we were discussing. Now we have to discuss some properties of the momentum as well. Okay, and then we will discuss the remaining topics. Okay, chalo, that's good. Okay, so what I've done is that what I have written the quantity of motion, mass of the body. Okay, chalo. Acha, before that, let me write down the formula of the momentum. I'm going to write it here. We denote with small p or capital P. It's up to you, but capital P is basically used for power, rate of doing work. But okay, so that's why I'm using small p. P is equals to m, mass into velocity. Okay, and it is a vector quantity. It depends on the direction. Momentum of a body is a vector quantity. Clear, everyone?
Yes, sir.
Okay, chalo, that's good. Okay, so as you can see this thing, that mass, if you can see this thing, that momentum is directly proportional to the mass. It means that higher the mass, higher the momentum will be of a body. Yes or no? We have done the example of a truck and a car in the last class. Do you remember? That if basically if a truck with lower speed hits the human, it will basically have greater impact due to the greater mass than the car, right? And similar to the car, so if it's going with a higher speed, so it will make impact on the body, but not that much of the you can say truck or the bus. Okay, so momentum depends on the mass. Clear?
Yes, sir.
Sure,
Yes,
that's
sir.
good. Okay, so now tell me, if the body is at rest, what will be the momentum?
Yes, zero.
Zero. Okay, Arhan said zero. Anan, Saad, Sara, Samya, and Arham. What do you say?
So zero.
Zero. Okay. Why? Like, okay, I got one more answer. Zero. Okay. Yeah, it's
Zero.
absolutely zero. Yes, yes, Anani, I got your answer here. Because you can see this thing. Because obviously, if the body is at rest, so velocity of that body would be zero. So v is zero, obviously. So momentum is going to be zero. Clear? So I'm writing it here. The okay. Just a moment. A body. Just a second. At rest, its velocity is zero. And hence momentum, its momentum will also be zero. Is my writing readable to all of you?
Yes, sir.
Check.
Yes.
Check. Clear? Okay, so about the now next thing is that about the momentum, that it is a vector quantity. Vector quantity are those quantity which have both magnitude and direction. Everyone, do you remember vector quantities?
Yes.
Right? Yeah. So momentum is a vector quantity. Because we are doing momentum before the second law of motion, because second law of motion based on the momentum. That's why we have to understand what momentum is basically. Okay? So हाँ, momentum is a vector quantity. Okay. Next thing about momentum is SI unit. So SI unit is simply the SI unit of mass and SI unit of velocity. If you multiply them, that would be your SI unit of the momentum. Clear? Is kg meter per second. Mass is kg, velocity is meter per second. Just okay. So this is the SI unit of momentum. Clear, everyone? Please let me know once if this is clear or not.
Yes.
Any doubt so far to anybody?
No doubt, sir.
Sure?
Yes, sure.
Sure, that's good. Okay. Sure. Okay. So you must have seen before that, right now, like in every part of the world, road accidents is a part of daily life, right? Because we have roads, so there might be some accidents on the road as well. So you must have seen that the accidents having which have suppose that car is at very high speed. That means that if the car is at high speed, obviously the momentum will be high. So the impact of the accident will also be greater than the car at lower speed. Okay, so accident could be more worse when the speed is high, when the velocity or you can say the momentum of a body is very greater than the lower one. Okay, so so basically momentum tells you the impact, how much impact it's going to be there on a body when it is struck. And you must have seen that suppose that a bowler, so most of you are very familiar with the cricket. Okay. So when a bowler bowls the ball, what happens is that it goes with a very high velocity. It's basically release the ball with a very high velocity. Suppose that instead of making contact with the bat, the ball basically strikes the stomach, arm, eyes, or head. So it will, you can say, it will make a very huge impact because the ball is at very high speed, like almost 150 kilometer per hour, 140 kilometer per hour. This is the average speed of a normal bowler. Have you heard one of the news in 2016? I think so. There was a Australian cricketer, Phil Hughes. Okay, I think so. Those who watch crickets or fond of cricket. So Phil Hughes was an Australian cricketer. What happened is that there was a bouncer bowled by the New Zealand bowler. So it's that ball struck on his head, and after 1 or 2 hours, or maybe a day after that, he passes away due to that injury. So you can say this thing that this is a very, very huge blow. So a single, you can say a very small cricket ball can also take the life of a people, can life of a single person, of an individual. Okay, so that's why momentum is very, you can say, important to understand. It basically tells you how much the impact is going to happen on a body when the body is in moving or when the body is motion. Clear, everyone? Okay, yeah. So I told you this incident because this was the very tragic incident in the cricket history. This happened in I think so 2015 or 2016, and he was only 26 years old. Okay. Okay. Now so this is okay. So now let's do a question based on the momentum. So question based on the momentum are not that much tough. They are simply straightforward. Okay. Okay. So question is saying that what is the momentum of a man having of mass 75 kg and when it walks with a uniform speed of 2 meter per second. So mass is given to you, first of all, 75 kg. Velocity is 2 meter per second. Okay. So as you know this thing that momentum is mass into velocity is equals to 75 into 2 is equals to 150 kg meter per second. Clear, everyone? Please let me know. Is this clear?
Yes, sir.
Any doubt so far to anybody? Just let me know right now.
No, sir.
Are you sure?
Yes.
Sure. That's ठीक है. So this is the momentum. Just a moment. Acha, I just wanted to ask, did you have any assessment in the previous class? Okay, let me check. You had assessment. Only three of the person. Arhan, were you there? Have you attended the last class, dear? Arhan?
No, sir.
No. ठीक है. Okay, Haider was. Sarah, were you there in the last class? Sarah Khan?
Yes, sir.
Sarah, why did you not attempt the assessment of the inertia? It's it's shown still pending. You were there in the last class. That's attendance is there. I think so. Arhan, you were all. Arhan nahi the. Arhan was not there. Yeah, Arhan was not there. Haider was there. Rafe, Furqan, Bhati. Hanan, Hanan, you were there in the last class. Have you done the assessment there in the last class?
I think so.
Yes, you have done. Yes, yes, yes. It's yeah. Sarah, after this class, stay for 5 minutes, okay? Don't leave without my permission. Check in. Sure. Okay, let me take one more question, then we'll start the second law of motion. Okay, so question is saying a body of 25 kg having a momentum of 125 meter per second, 125 kg meter per second. We have to calculate the speed. So mass is 25 kg. P, that is momentum, is 125 kg meter per second. So writing, always write the formula before putting the values. Okay, it tells you that it basically it gives you the idea to the teacher that the students knows about the concept very well. Okay, so it is 125 divided by 25 meter per second. So it will cancel this 5 times. So 5 meter per second is the answer. Is this clear to all of you?
Yes, sir.
Okay. So I'm giving you a question. Solve the two parts of these questions. Okay. And let me know the answer one by one. Okay, solve it and let me know the answer.
Sir, the SI unit is meter per second.
For SI unit for
Momentum.
kg meter per second. Kg meter per second.
Okay, sir.
Yeah. Okay, I got the first answer by Arham. ठीक है Arham. Okay. I got two more answers by Hanan. Okay, Hanan. Okay, Hanan. Okay, Arham. Okay, I got one more answer by Simon. ठीक है. Okay, let's do it together. ठीक है. Okay, let's check whether we have got the right answer or wrong answer. The solution. So, question is saying the momentum of the following is to so basically for A part, the mass of the one more answer I got it by Sat. ठीक है Sat. Okay, let's check it. So, mass of the elephant is 2000 kg and body of the velocity is 5 meter per second. ठीक है. So, momentum is going to be P is equals to mv. ठीक है. So, P, okay, I got one more answer by Sarah. Okay, Sarah. ठीक है. 2000 into 5 is equals to 10,000 kg meter per second. Clear, everyone? Any doubt so far to anybody for this? So this one is correct. Okay, those who have got 10,000 kg meter per second as the answer, that is absolutely correct. Okay. Next is mass of the bullet is 0.02 kg and moving at a speed of 400 meter per second. So you can see this thing that bullet, you can say travels with a very high speed. So the momentum of this bullet is going to be P is equals to mv. Okay. So P mass is 0.02 into 400. So it be 8 kg meter per second. This answer. Please let me know, everyone. Is this clear to you or not? Any
Yes,
doubt
sir.
to anybody?
Yes, sir, this is clear.
Sure? Everyone clear?
Yes, sir.
Sure. That's okay. So this is the basically the you can say the numericals related to the momentum. So these kinds of numerical will be there. Momentum does not have that much very complex numericals. Simple numericals will be based on the answers. Sorry, on the formula basically. Okay. Okay. Now let's move forward to the next topic, that is momentum and second. Okay. Let me. Okay. Okay. Here we are going to cover only momentum. Let's cover the second law of motion in the next, because motion. Second law of motion. Okay. So now basically we have done the momentum. So the thing that we are going to discuss is about the second law of motion. So basically, second law of motion gives the relationship between the force, mass, and acceleration. It tells you about that, how they are connected to each other. Okay. So basically, second law of motion says that rate of change of momentum is directly proportional to the applied force in which the body is moving. So it means that, let me write down the second law of motion first. Okay. Suppose that, let's go थोड़ा सा explain करते हैं with the example. Suppose this is a truck, this is a car. ठीक है. So here, if basically you can see these two have different masses, right? So when two bodies, one is heavy, obviously this one is heavy. This one is light. So car is always, you can see, like in comparison to, you can say, truck, it's going to be very light object, right? So when the two bodies having, basically one is heavy and another one is light. So when the same force acts on these two bodies, suppose that I'm, you can say, this 50 Newton force, 50 Newton force, right? So 50 Newton force will be applied and 50 Newton force on the applied on this same tube. Okay. So you can see this thing. This is a light, so it will attain a higher velocity. It will attain the high. It will basically move fastly than the heavier truck. Yes or no? Basically, you can see this thing. Suppose that there are two person basically pushing a car, and they are same two person are pushing the truck. Which one will move? Obviously, the car is going to move. Yeah. So here same is this. So 50 Newton force is applied on the light car, you can say light object, and 50 Newton force is applied on the heavy object. So the velocity attained by by the light object will be greater than the velocity attained by the heavier object. But the momentum will be same. That's the catch in this law. Momentum will be same. This is justified by the second law of Newton. Okay. Let me write. Okay, so this is the example. Let me write down the statement. The rate of change of momentum of a body is directly proportional to the directly proportional to the applied force takes place in the direction in which the force acts. Okay. So basically, it's saying that force is directly proportional to rate of change of momentum. Okay. So change in. So rate means it is divided by time. By time. Okay. So this is a you can say this is a small derivation, something like that. So this basically comes in the exam as a 3-marker question. State you can say second law of motion and derive a relationship between the force, mass, and acceleration. Okay. So this only 3 lines calculation is present here. So suppose that we are going to suppose that body is moving with some initial velocity and it has some final velocity as well. Rate of change of momentum means that the velocities are different. Rate of change of momentum. The body is moving with some initial velocity u. So its change is there in the momentum. It means that velocity is also changing. Mass is not going to change of that body. Only the thing that is going to change is the velocity. Okay. So initial velocity is mu and mv is the final velocity. Oh, sorry. U is the initial velocity. V is the final velocity. Okay. So there is a you can say word use change. It means that initial momentum will be something else and final momentum will be something else. Let's relate it in the derivation context. Okay. Let's consider body of mass m having initial velocity u and final velocity v. Clear? And before just a second. Initial final velocity के बाद लिख लेता हूँ कुछ और and momentum will be and initial momentum will be mu. Okay. Mu will be the initial momentum. So it means that if I have to change the momentum, I need to apply some force on that body. It means that changing momentum means changing the speed of a body. So it will change the momentum automatically. Everyone agrees with the point?
Yes, sir.
Yeah. So suppose
Yes.
that, yes, is everyone saying something? Is anyone saying something? Please let me know once. Anyone? Anyone having doubt? Okay. Suppose a force F acts on this body for a time t and causes a final velocity So it means that if a body, basically if you are exerting some force on a body, so it means that the velocity of that body is going to change. So now the initial the velocity has changed to final velocity v. Okay, after applying some force for a time t, to become clear. So the final momentum would be mv. Will be mv. Okay. Now, according to the second law of motion, force is directly proportional to the change in momentum. So change in momentum is nothing but final momentum minus initial momentum. That is how we calculate change, everyone. Please say yes or no.
Yes, sir.
Right?
Yes.
Okay. Divided by time. Rate of change, we are talking about rate of change, so divided by t. Okay? So now, this will be changed to F is directly proportional. Can I take M common from both the initial and final momentum? And it will be here inside V minus U divided by T will be left. Okay? Divided by T is, this is left. Clear, everyone? So as you can see this thing, V minus U by T is denoting the rate of change of velocity. Which quantity is represented by rate of change of velocity? Tell me. Which quantity is represented by rate of change of velocity? Now that's why I was continuously saying to revise, because this chapter is connected to the motion chapter. Now everyone is like, nobody has any answer? Nobody. Sara, Hanan, Arhan, Arham, Saad, Samia. Rate of change of velocity. Which quantity is defined as the rate of change of velocity? And that is the most basic, like these were the fundamentals of the motion chapter that I am asking right now.
Acceleration.
Okay, Arham said acceleration. What about rest of you? Only one answer given by Arham. Hanan, Arhan, Sara, Samya, and Saad.
Sir, what was the question?
I was saying,
Acceleration.
okay, Hanan said, I was saying the rate of change of velocity is defined as.
Sir, acceleration.
Sir, acceleration.
Now the answer given by one person has moved to everyone. Yeah, it's acceleration. Now you got it. Why I was continuously saying to revise the motion chapter? Because everything is related to each other. So these three chapters, motion, force laws of motion, work energy. These three chapters are like brothers. If you do not do the revision of the previous chapter, you are not going to understand the further concepts. I'm bluntly saying it. So you have to revise at all, at any condition, at any cost. I hope now you got my point. Now you can see your position. You are not even answer this. You are not in the position to answer a simple definition. Rate of change of velocity is acceleration. So you have to introspect yourself and take a look where you are standing right now before your midterms. We have done one whole chapter, so it's time to revise right now. Okay. So this is, so here I will be writing as V minus U by T is basically represents rate of change of velocity, that is acceleration. Okay. This is called acceleration. So in place of V minus U by T, I'm going to write A. MA. Now to remove this proportionality sign, I'm going to introduce a constant that is K. Okay. Is equals to KMA. Now basically by the calculations, where K is a constant, by the calculations, the SI unit of the K is about to be 1. So that's why so multiplying 1 with the M into A, it's nothing but same. Okay. So where K okay. Thus value of K is 1. Okay. So the thing that comes out to be is force is equals to mass into acceleration. This is the most famous formula that we have, like basically use in our day-to-day life for the examples. Okay. Force is equals to mass into acceleration. This is the formula that we usually hear from everyone. Yes or no, everyone? So that's how it is derived. This is not a very lengthy derivation. Only three steps are there. Force is change in momentum. Okay, this is the thing that you have to write. So basically explain what is happening here right now, because teacher will say that how did you got force m into v m in mu time. Okay, so that's why you have to say that body is having mass, initial velocity is u, so momentum will be initial momentum will be mu. So force acts on a body, so obviously there would be a change in momentum, right? So body, if I'm applying some force, so the body will change its position, obviously. So body is already moving and applying some force, it means that body will be changing its velocity. So that leads to the change in momentum, mv minus mu divided by t. So I've taken m as common, so v minus 2 is representing the rate of change of velocity, that is acceleration. So that's how you got acceleration. So k value is 1 by the calculation. So okay, so if you write this thing, that would be enough. Now please let me know, everyone, is this clear to you or not?
Yes. Yes, sir.
Everyone clear with this second law of motion?
Yes, sir. Sure.
Check, I got one chat. Check. Okay, so this second law of motion gives us the relationship between the force and acceleration. It means that if there is any force on a body, so there would be some acceleration, obviously. Okay, there would be some acceleration if I'm applying some force on a body. Clear? So I'm writing it here, the first point about the second law of motion. Newton's of motion. Everyone, I'm requesting from here to here. This is very important, because when I was in ninth standard, this question twice in my mock test, which is basically in the before the final terms and in the midterm as well. 3 marker question. Explain. You can say write down the second law of motion and derive the relationship between force and acceleration. So this is very important and a very hot topic from the derivation point of view in the exams. So please mark it as important. This is a 3 marker question directly. No change. Copy pasted. There are very high chances, okay, for the midterms as well as for the final terms. Okay, this question appeared in the twice in my exams, midterm and the mock test. Okay, gives us a relationship between force acceleration. B part. So B part is second law of motion. This second law of motion gives us a method to measure the force in terms of mass and acceleration. Clear? Measure the force in terms of mass and acceleration. It means that force can be measured, force can be identified, or you can say calculated in terms of mass and acceleration. Clear, everyone? Okay.
Yes, sir.
Okay, one more thing. So like right now, this class is about to end. So there is one homework, like apart from the questions, is that you have to revise the equations of motion before coming to the class. You have to solve numericals from the NCERT, from the book that I have given to you. So you have to solve the numeric, and you can also solve the numericals that we have done in the class based on the equation of motion. So because this second law of motion involves the equation of motions. So it's a very humble request to all of you to revise the equations of motion before the next class. Okay? At least say yes or no. कुछ तो बोलो.
Yes, sir.
ठीक है?
Yes, sir.
Sure, let's go. Okay. So now let's do a little bit modifications in the suppose that force is mass into acceleration. So acceleration would be force by mass. Say yes or no.
Yes, sir.
ठीक है? It means that acceleration is directly proportional to the force applied and inversely proportional to the mass. It means that higher the mass, lower will be the acceleration. You can see this thing. If you increase, higher the force you will apply, you will be having higher acceleration, greater acceleration. Greater the force you will apply, you will be having greater acceleration. So, agree with me or not?
Yes, sir.
Right? Suppose that, let's compare. एक example में compare करते हैं. Truck, car. I'm applying same force here, 100 Newton. 100 Newton. Which car will have the higher acceleration? A1 or A2? Which one will have higher acceleration? Force applied is same on both the cars.
A1.
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 A1. Obviously, A1, you can see this thing, car is having very small mass. It means that smaller mass, higher acceleration. Force is same here. Okay, I'm just giving example. Okay. Clear, everyone? Why the mass matters in this calculation? Higher the mass, lower will be the acceleration. Clear? That's why it is said inversely proportional to the mass. Is this clear to everyone? Please let me know once or not.
Yes, sir. Yes, sir.
Okay? Chalo, that's good. So here the C point is the acceleration produced in a body. इसको यहाँ पे लिख देता हूँ. C point यहाँ से लिख देता हूँ. This is C point. ठीक है? Acceleration produced in a body is directly proportional to the force acting on a body acting on it and inversely proportional to the mass of the body. Please let me know, everyone, is this clear to you or not?
Yes, sir.
Yes, sir.
Okay? Sure. So if I basically, one more thing is that SI unit and I've told you that force is a vector unit, force is a vector quantity. So and SI unit for force is Newton. Clear?
Yes, sir.
अच्छा before that यहाँ पे मैं लिख देता हूँ एक statement लिख देता हूँ. C part 1 and 2. This is 1. this is 2. Okay. The thing is that if the mass of the body is doubled, yeah, its acceleration will be क्या होगा? What will happen to the acceleration if the mass is doubled? बोलो, any idea? देखो,
It will decrease.
mass is doubled, so you can see this thing, force is constant, force is not going to change, so it will half ना, देखो half हो रहा है, देखो ये
Yes,
आप ये आपका half हो रहा है ना, देखो another 2 is basically introduced, so it will become half. Clear? So it will be
yes,
half. ठीक है, half. Okay, and if the mass is halved, the acceleration will get doubled. Okay, but the force remains constant. Okay, the condition is that in this case the force remains constant because we are comparing how you will understand it. Okay, and and if the mass of is halved, then acceleration will get doubled. Provided the same force. Okay. Remains the same. Please let me know, is this clear to all of you or not? यहाँ से मैं थोड़ा सा स्पेस करके
yes, sir.
ठीक है. Please let me know if this is clear to you or not.
Yes, sir.
ठीक है. अच्छा, एक चीज मैं छोटी सी कैलकुलेशन यहाँ करके दिखा देता हूँ. ठीक है. So the mass of the हाँ. So suppose that यहाँ पे now we are talking about that force. This is for case 1. ठीक है. Force is same as it is. ठीक है. Force I'm not going to change. So if the mass of the body is doubled, so देखो A would be F by M. ठीक है. Now what happened is that M2 is twice of M. ठीक है, doubled. We have and force is same. ठीक है, force will not remain same. F2 is F. ठीक है. I need A2. A2 would be F2 by M2. बोले इसे everyone yes or no? So F2
Yes.
is already F. M2 is 2M. देखो, this is suppose this is A1. This is A1. This is 1. ठीक है. So A1 F1. ठीक है. So you can see this thing and F1 here is F already. ठीक है. देखो, this is nothing but A F by M. इसको मैं 1 ही कर देता हूँ सबको. F1 by M1 is A1. So now A1 by 2. So देखो, acceleration has become half. That's what I'm saying. If the mass get doubled, acceleration would be half. Clear? Is this clear
Yes,
to
sir.
you or not? Second
Yes, sir.
case. Second case. F1 is F. ठीक है. M1 is M. ठीक है. F2 is F. M2 is half कर दिया हमने mass. Now we have half the mass. ठीक है. Now I have to calculate the A2. ठीक है. So A2 would be F2 by M2. बोलो yes or no everyone.
Yes, sir. Yes.
F2 by A2. ठीक है. F2 by M2. So F2 by M2. तो देखो F2 is nothing but M and M by 2. So this is a double division. So this will go in the numerator. Bolo yes or no? So this would become twice of F1, twice of F by M. So F by M is nothing but acceleration A1. Bolo yes or no?
Yes, sir.
Now it will become 2A1. देखो acceleration double हुआ ना, mass half करते ही.
Yes, sir.
ठीक है. Clear? सबको हुआ ये clear? ये बोलो. Is this
Yes,
clear
sir.
to you everyone?
Yes, sir. Yes, sir.
That's how these calculations proceed. Okay. Any doubt to anyone so far?
No. No, sir.
Chalo, that's good. So just a moment. So there will not be any assessment in this after this class, because I need to do some I wanted to have some numericals in the class before the assessment. So we will do the assessment in the next class. Okay. Clear?
Yes.
So okay, so this like the theoretical portion of this topic is done. Okay. And we will do some numericals based on this topic. How do we use this like how do you use second law of motion in real life, like while catching a ball? So how many of you play cricket? Arhan, Sara, Saad, like I don't think so that girls play cricket. Like, do you have interest, everyone? Samia, Hanan and Sara in cricket?
Yes, sir.
Acha, interested. Chalo, that's good. Like, good to hear that. Chalo, ठीक है. So when you catch, suppose that a catch basically you can say catch like the ball is coming from a very high height, very higher point. So what you will do is that when catching, so you will basically close your hands and take a little bit in the backward direction to basically observe the impact of that ball in the hands. Okay. So this is the this is the application of second law of motion. I will explain. And when you jump, so what you do, you basically bend your knees. You basically sits like in this squat position. When you jump from a higher point, you do not just stand on the ground. Instead of that, you basically jumps like a frog. How many of you have observed this thing? Have
Yes,
you
sir.
ever observed? So this is the
Yes,
reason. Okay, so this is the application of second law of motion. I will explain it to you as well in the next class. Okay, so we'll do some conceptual points and along with the numericals. So your homework would be practicing the question based on the equations of motion. Clear?
Yes, sir.
Okay.
Yes.
Okay. So that's all for this class then. Sarah, just stay for the 5 minutes. Give me a 5 minutes. Everyone can leave. Thank you.